What are you doing? Don't use the wrong value. All right, guys, I'm going to show you these because I do think that you struggled more than I anticipated, just to be honest. We don't keep secrets here. So, where's the remote? Does somebody see a remote? Okay. So, eyes up here for me quickly. We have a couple minutes left here, and then we're going to move on. So I wanted you to be exposed once again to the cumulative nature of these particular types of questions. So eyes up here. Sorry, this is a little bit slow, but I'm here. Okay. So if you categorize on the spot and then categorize and then think about how you solve those types of problems, you should be fine. The very first one is a weak acid. You know weak acids have a Ka. You got their Ka, you set up an icebox, you neglect, yes, you're good. Once you get X, you got your H plus concentration, which would then give you pH of 4.53. Thumbs up if you made it through that one. That's a weak acid. You're very familiar with that. Now, what some of you guys got stuck on, you didn't categorize off the bat what this next one was. Well, it's a salt. You know that a salt is considered acidic, basic, or neutral, but it's not an acid or a base, right? So you have to find the ion that acts acidically or acts basically by the donation or acceptance of an H plus. So the K is not going to react. It's going to make potassium hydroxide, which is a strong base, totally ionizes, nothing happens, and no reaction. The hypochlorite ion will react, and in this case, it's acting as a base because it accepts an H plus from water. And so there's your little icebox there. The hypochlorous acid is made, hydroxide is made, so double whammy, it does definitely act as a base because it's making hydroxide. So if it's acting as a base, you must use the Kb from its Ka. Well, hypochlorous acid, or hypochlorite, is the conjugate base of hypochlorous acid. So that conjugate base coming from the conjugate acid of hypochlorous acid means the Ka and Kb go together there. So that's where we use our Kw. Kb is 2.857 times 10 to the negative 7th. Set up your icebox, solve for X. This X is not hydronium. This X is hydroxide. Who saw that was hydroxide? Awesome. Okay, because sometimes you're like, you get in the groove and you're just going, but you do need to reflect back to your icebox. You see it's hydroxide. You do 14 minus the negative log of hydroxide, and you get 9.93. Yeah? Awesome. Okay, and the last one is going to be a mixture example, and the mixture includes the common ion, and that common ion is the hypochlorous acid along with the hypochlorite. Potassium is just a spectator ion here. So what you may have written out first was basically the dissociation that you did in the very first A part. And so the hypochlorite ion already has a specific initial, so does the hypochlorous acid. And then minus X plus X plus X, you'll notice that both those X's are neglected, so therefore X is equal to the Ka value. Plugging that in gives you an intermediate. And what you should recognize is that this hypochlorous acid by itself was what, like 4 pH, 4.4 something, whatever it was. And so now I'm adding this salt, which has a more basic nature to it, and so that makes sense. The salt that's a basic salt increases the pH to 7.46 from its original of whatever it was, 4 or 5. So that should make sense if you had to explain why the common ion effect is impacting the pH. Do we need to do more of these right now? Okay, for your leisure time, there are more. There's a couple more down below on that first one, and then the second set of questions, which you have in front of you, relates to ammonia. So to give you the context of things, how do things act basically, and then you find the KH and the KBs. But if you understand how to do it, you can do it 1,000 times, but I just want to make sure you have what you need, okay? So yay or nay, more of these, yes or no? Nay? Okay. All right, so do me a favor, grab a laptop. And I would say maybe 1 laptop per pair, or 2 if you want. We're going to do a diprotic titration example. I'll show you where this is on my website as well. All right, so while you're grabbing a laptop, I'll tell you, this is the paper I gave you yesterday. Find the paper from yesterday. It says Diprotic Titration Excel on it, or Unknown Dry Lab. It's a graphical analysis of the diprotic titration. Got a bunch of numbers and a chart on it. Thank you, Sean. Yeah, all the others. Find this. Okay. So I'm leaving this to you mostly. I do need to make sure that we're really trying our best to stay on task, because I adjusted the schedule so we could have more review time next week. So work with me so I can keep that for you. But this diprotic acid lab versus doing the titration itself, you need to understand how the pH can be, pH and other information can be pulled from a titration graph itself. So this is kind of a sketch of that graph, and I walked through yesterday how you see the two equivalence points. But the reading up top gives you some context to the diprotic acid and how does it react with the base. And then it gives you a little bit more reading about how to understand the equivalence points and what data you can pull from that. That would be important. After the initial reading, which you absolutely need to do some close reading of that so you can pull out the information that's pertinent to you, it gives you sample data. So this is the sample data. It gives you 0.119 grams of the diprotic acid. It gives you the pHs at different volumes of the base added. I have already graphed this for you on an Excel file. That way you don't have to key it in yourself, unless you want to. But I think you guys know how to use Excel. I use Excel a lot in college chemistry. I just want to make sure you're comfortable with that. But it does tell you how to do a scatter plot. But if you go to my website right now, kind of while you're logging in, you'll see under Unit 8, diprotic titration lab data or something like that. I'll show you where it is on my website. But I already have this graph for you, so you can pull the data straight from there. At the bottom, it tells you how to analyze that data. So it'll tell you, and if you would like, you can use this teeny graph here to do your data points, to just kind of make a note of what they truly are, or you can graph it yourself, or I can print you an Excel if I need to. But it tells you how to analyze here. But I'm not going to walk through each of these steps because you can read it as you go. Okay. And at the end, what you're identifying is the acid that this specific diprotic acid is based on the molecular weight that you find. Okay, so I'm going to leave that to you for now. If you have questions as you go, let me know. But working in teams of 2, maybe in 1 team of 3, because I think I got an odd number today. But you have all this in front of you, okay? And then at the very bottom, it starts to relate Ka to pKa, and then also something called the half equivalence point, which we're going to jump into more information with that tomorrow. All right, guys? Yeah, we got this. Thanks, guys. You're awesome. Jeez, man.